So in today's class, we are going to be looking at the sum formula for the geometric progression. The sum Sn, Sn indicates the sum of the first n terms of a geometric progression. The sum of the first n terms of a geometric progression is given by a, the first term, times 1 minus r. R is the common ratio, to the power of n, bracket close, divided by 1 minus r. Okay, so a times bracket 1 minus r to the power of n divided by 1 minus r. So if your common ratio is between -1 and 1, you can use this form. You can use this form. And if you take minus common, from this, okay, from the numerator and the denominator, it's going to be r to the power of n minus 1 over r minus 1. The minus are going to be cancelled out, and you are going to get this expression. Now you can use this expression for the sum Sn equals to a times r to the power of n minus 1 upon r minus 1 when the common ratio is greater than 1 or less than equal to -1. Okay, but when you are dealing with the equation, you can use any formula. It doesn't matter whether you use this form or this form, because eventually the answer is going to be the same for this sum. Now in our syllabus, we just have to make use of these formulas. So I'll tell you how to use the formula. So let's consider this question. Find the sum of the first 12 terms of the geometric series. Now the question has already mentioned that this is a geometric series. If the question would not have mentioned, how would we find that this is going to be a geometric series? What was the condition for the geometric progression?
Common ratio is always the same.
Common ratio, there's going to be a common ratio between the consecutive terms. So 6 divided by 3, that is 2. 12 divided by 6, that is also 2. 24 divided by 12, that is also 2. So we are dealing with a geometric progression with a common ratio of 2, and the first term is 3. And there are 12 terms. Sorry, it's an infinite series, as you can see. Okay, but you just need to find the sum of the first 12 terms. The sum of the first 12 term means S12. Okay, so if you recall, the formula for Sn in a geometric progression is a times r to the power of n minus 1 over r minus 1. I'm using this form because the common ratio is greater than 1. Okay, so S12 is going to be a, the first term, that is 3. The common ratio is 2. 2 to the power of 12 minus 1 divided by 2 minus 1. Now you can use your calculator to evaluate the result. 2 to the power of 12 minus 1 times 3, 12,285 divided by 1, that's going to be 1. Is the first example clear to you guys?
Yes,
you just
sir.
have to remember the formula and use it. Sorry, is there any question?
No, sir, just clear. It's clear.
I'm sorry?
So it's clear. It's clear.
There. Okay. All right. Now, this question says that the third term of a geometric progression is 9 times the first term. Can I write it like this? The third term is 9 times the first term. Okay. I'm translating this statement into an equation. Now, the next statement says the sum of the first 6 terms, that means S6, is K times the sum of the first 2 terms, that is S2. Okay. I need to find the value of K. So to find the sum, I need the first term and the common ratio. Okay. So I'll solve these 2 equations simultaneously. In a geometric progression, guys, what is the third term equal to? Remember the
AR
term formula?
squared.
It was
Yeah.
AR to the power of n minus 1. So the third term is going to be equal to AR square.
Yeah.
And the first term is equal to A.
A, so 9A.
So AA is going to be cancelled out. R square is going to be 9. Okay. Now I'll just let R square be equal to 9 over here. And I'll go to the second equation. What is S6 going to be equal to? What was the formula for Sn? N upon 2. Sorry. The formula for Sn was A times 1 minus R to the power of n over 1 minus R. So as per this formula, how are you going to evaluate S6? Would you agree that the first term is going to be A? 1 minus, I don't know the common ratio yet. Okay. To the power of n, that is going to be 6 divided by 1 minus R. Is that correct?
So isn't R plus minus 3?
Yes, but I'll just stop till over here and
Right.
I'll let you know why I'm saying that. You are right that R can be plus minus 3. Okay. But I just need to solve the right hand side first. Okay, Hassan, what is S2 going to be equal to?
It'll equal to A 1 minus R squared over 1 minus R.
Over 1 minus R. Okay. Would you agree that 1 minus R and 1 minus R can be resolved from here?
Yes. Also A.
Also, A is going to be cancelled out. So I'm going to be left with 1 minus R to the power of 6 equals to K times 1 minus R square. Okay. And what is going to be the value of K? Would you agree K is going to be equal to 1 minus R to the power of 6 divided by 1 minus R square?
Yes.
Right?
Yes.
Is everyone with me till here? Now,
Yes.
okay. So instead of R to the power of 6, can I write R square to the power of 3? Using the rules of indices, can I write it like that? 1 minus R square to the power of 3. Can I write it like this? Does anyone have any objection?
No.
R to the power of 6 is same as R square to the power of 3. Now, what I'll simply do is I'll plug R square value that was 9 over here so that K value comes out to be 1 minus 9 cube divided by 1 minus 9. So guys, solve this and give me the value of K.
Sir, it's 91.
It's 91, right? So K comes out to be 91. Okay. All right. Guys, I'm moving ahead now. Any questions till here? Please let me know right now.
So like how did you figure out that you were supposed to like factorize the power and
No.
then
I just figured it out because I had solved it initially, okay, while teaching other students. But let's say if you would be solving, you could have taken plus minus 3. And when you're going to be plugging R as either plus 3 or minus 3, it is going to give you the same result. Okay. Plugging it plus 3, plugging R as plus 3 or minus 3 would generate the same result. So there is going to be only a single value of K. Instead of 2, there is going to be a single value of K, that is 91.
Thank you.
Okay. All right, guys. Now this is the new concept or the next concept. infinite geometric series. Okay. Okay, I would like to explain this using this example. It's a square, okay, of side 2 by 2 units, 2 by 2 centimeter. What is the area right now for this square?
4.
4, right? So the area is 4. Now, if I divide this into 2 equal parts, what is the area of the
2.
remaining rectangle going to be? It's going to be 2. Then if I further divide this, what's the area of this rectangle?
1.
1.
Okay. And then I further divide this.
0.5.
Then I further divide this.
0.25.
0.25.
Then I further divide this. 1 upon 8.
0.125. Yes.
And then
One.
1 upon 16. Okay. Would you agree that if you, okay, I do agree that this is a finite square right now. But just to give you an idea, if you look at this series, would you consider this to be a finite series or an infinite series? It's a finite, it's an infinite sequence, right? The series, the difference between the difference between a sequence and a series is that series has plus sign over here. Okay. Now, I could have I could have divided this, kept on dividing this square into further smaller and smaller parts. So I'm going to be getting the next value like this. Okay. So this is a infinite series. But would you agree with me that although it's an infinite series, it is going to have a finite sum? What is going to be the area of all the rectangles and the squares that you are going to have? What is that going to be equal to? What is going to be the area? The total
of the
total area is going to be equal to
4. 4.
total of the rectangle.
4, right? So although this is a infinite series, but it has a finite sum. And that finite sum is called the sum to infinity. Okay, that is called the sum to infinity. Sum of the infinite series is the finite sum, and in this example it is 4. Okay, so if you look at this series, what is the first term over here? The first term is 4. Okay, and what is the common ratio between the consecutive terms? For this sequence, what is the common ratio?
2.
The common ratio is the ratio of the next term divided by the previous term, right? So 2 upon 4, that is 1 upon 2. So the first term is 4 and the common ratio is 1 upon 2. Now please remember that in a series, when the common ratio, in a geometric series, when the common ratio is between -1 and 1, this series is called convergent series, which simply means that its sum is going to converge to a value. Okay, and that value is called the sum to infinity. And it converges to a finite number. And the sum to infinity of a geometric series is calculated by the formula a upon 1 minus r. Okay, provided that the common ratio is between -1 and 1. Not all geometric series are convergent, because sometimes maybe the ratio is 2, or sometimes the ratio is -3 upon 2. Okay, so these are divergent series. Only the convergent series will have sum to infinity. And that convergent, how would you recognize whether that geometric series is a convergent series? when the common ratio of that series is between -1 and 1. So for example, minus 0.5 or plus 0.5 or 1/2 or 1/3. So if the common ratio lies between -1 and 1, that series is a convergent series. And this convergent series is going to have a sum to infinity, which is going to converge to a finite number. If you're asked to calculate the sum to infinity, you're going to use this formula. S infinite is equal to A upon 1 minus R. Okay, my bad. So the first term is 2 over here. Okay, I'm starting with 2. The first term is 2, as in this example. So what is going to be the sum to infinity for this? Sum to infinity for this is going to be A upon 1 minus R. The R value is 1/2. Okay, and the A value is 2. Okay, so what is 2 divided by half? That is going to be 4. Okay, so the sum to infinity is 4, and we can see that for this rectangle, the sum to infinity is going to be 4. If I add this area 2 plus 1 plus half plus 1/4 plus 1/8 plus 1/16, and if I keep on adding all the areas, I would be getting 4. That is the finite sum. So let's look at this question. The first 4 terms of a geometric progression are 5, 4, 3.2, and 2.56. These are the first 4 terms. Write down the common ratio. The question has already mentioned that it's a geometric progression. So you don't have to prove that it's a geometric progression. You just have to write down the ratio. What is the common ratio? How do I calculate the common ratio?
5 divided by 4 divided by 5.
Yeah, it's the next term divided by the previous term. So the common ratio is 4/5.
0.8.
Is 0.8. Is the common ratio between -1 and 1?
No.
Yes, it is.
Yeah.
Okay, so then the sum to infinity is going to exist. So to calculate the sum to infinity is A upon 1 minus R. The first term is A, that the first term
25.
divided by 1 minus R, that is 0.8. So what is 5 divided by 0.2?
25.
25. So that is the maximum sum this geometric series can have. Okay, if there were even other terms, the maximum sum the geometric series can have is 25. Make sense?
Yes,
Yeah.
sir.
Okay. The geometric progression has a common ratio of -2/3, and the sum of the first 3 terms is 63. Find the first term of the progression. This question says that the common ratio is -2/3, and the sum of the first 3 terms is 63. Sum of the first 3 terms would mean S3 is 63. Okay. Now, what is the formula for the sum of a geometric progression? A times 1 minus R
1 minus R.
over 1 minus R. Okay. So the first term is not known to us. The ratio is -2/3 to the power of 3 divided by 1 minus -2/3, and the result is going to be equal to 63. Guys, use your calculator and give me the value of A.
So like if I take 1 minus -2/3 and the other side, I would say 1 plus 2/3.
Yes. Yes, you are right. If you are going to multiply this 1 plus 2/3 with 63, you are going to get 105. And then you can divide it by this number. -2/3 to the power of 3 plus 1. Okay, that's some value around 1.296. $105 divided by answer. Okay, if I divide this, I get exact value as 81. If I use the calculator, stored value in the calculator and divide 105 with this, I get A as 81. Okay, so the first term is 81. Now, the second part is asking for the sum to infinity. Why do you think the sum to infinity exists?
The common ratios between -1 and 1.
The common ratio is -2/3, which is between -1 and -1. So it is going to be a convergent series. So A value is 81 over 1 minus R. The R value is -2/3. So what is the maximum sum this geometric progression can have?
Sir, it's 48.6.
48.6. Okay. Any questions till here, Manu?
No, sir.
Okay. Zores, any question?
I'm confused. Sir,
Yes,
how did you get like, sir, 63 multiplied by negative 2, 3 multiplied by 2/3 multiplied by 1.
No. First of all, you are going to calculate this in the using the calculator. It's going to be 1 plus 2/3. 1 plus 2/3 is going to be multiplied by 63. You get 105.
Okay, yeah, okay.
Then you divide this value over here by 105, so you get 81.
Okay, got it, sir.
Okay. The first, second, and the third term of the arithmetic series are x, y, and x square. So the first, second, and the third term. Okay. The first term of an arithmetic series is x. Okay, just a second. So they have given you three terms. They are saying that these are the first three terms of a arithmetic series. The first, second, and the third term of a geometric series are x, x square, and y. Given that x is less than 0, find the value of x and the value of y. Now, how can you come up with the equations to do that? As far as the arithmetic progression is concerned, what is so significant about this progression? What is it like? How do you identify that it's going to be an arithmetic progression?
A plus B, A plus 2D. Oh, sorry, common difference.
Common difference. So would you, if these are the first three terms, would you agree that the difference between the first two terms is going to be the same as the difference between the next two terms?
Yes.
So does that help you in forming the equation? The difference y minus x is going to be the same as x squared minus y. Okay.
Okay, yeah.
Okay, now as far as the geometric progression is concerned, there is going to be a common ratio between the consecutive terms. So the common ratio between the first and the second term is going to be the same as between the second and the third term. So x squared upon x, the common ratio should be the same as
X over
Y.
X square over Y.
Y
y
over X.
upon x squared. Okay. Now if you simplify this, what do you get? Y as x cubed, right? If you cross multiply this, y is going to be equal to x cubed. Is that correct?
Yes.
And if you simplify down the first equation, that's going to be 2y equals to x squared plus x. Now you solve these two equations simultaneously. You substitute equation number 2 in equation number 1. You are going to get 2 times x cubed equals to x squared plus x. 2x cubed minus x squared minus x equals to 0. Can I do that? I'm taking all these
So,
Yeah.
all these two terms on the left hand side.
3 plus 2 plus 1 equals 0.
Sorry,
No, sorry. Everything is fine.
that's fine. Okay.
Yeah.
Now I need to solve this
Sir?
equation for x. Yes, any questions still here?
sir, I was saying x square over x equals to y over x square. If you cross multiply, they will cut them. Like we'll say x square minus, they will cancel each other.
Yes, so this is what I've done over here. So x square times x square is x to the power of 4. Y times x is yx. Then you divide x on both the sides. So y is going to be equal
Okay,
to x cube.
okay.
Okay, and then you plug in y as x cube in the first equation. You're going to end up till here. Okay, then you can take these two terms on the left hand side. So 2x cube minus x square minus x is equals to 0. You can take x common out. You're going to get a quadratic equation 2x squared minus x minus 1 equals to 0. Is that correct?
Yes,
So would you agree that these are the two factors? One value of x is 0 and the other factor is
yeah.
2x squared minus x minus 1 is 0. Okay, guys, please solve this quadratic equation and give me the two values of x.
Sir, it's 1 and negative 1 over 2, that's 0.5.
1 and
Negative a half.
Negative,
-half. Okay. Since the question says that x is less than 0, which value are you going to pick?
Negative a half.
negative 1 over 2.
-half. So that's the value you're going to be taking now. If x value is -half, what is the value of y going to be?
Sir, 1.
So you can plug this value of x back into this equation. So -1 upon 2, the whole
Negative 1 over 8.
-1 upon 8. So that's the value of y. Okay. So you were able to formulate equations and then solve them simultaneously to get the values of x and y. Now the second part says, find the sum to infinity of the geometric series. Okay. So I'll do that on the next page. The sum to infinity for the geometric series. The geometric series was, the first term was x, the next term was x squared, and the next term was y. This is geometric progression. Okay, now guys, we have the value for x. So x value was -1 upon 2. Would you agree that the next term is going to be 1 upon 4 and y value is -1 upon 8 and so on? What is the first
Yeah.
term over here? -1 upon 2, right? What is the common ratio?
So 1
Common
over
ratio is
4
x
divided
squared
by 1
upon x,
over
that
2.
is x, and x value
Negative
is
a half.
-1 upon 2, -half, right? Now you are being asked to calculate the sum to infinity, that is a upon 1 minus r. A value is -half, r value is also -half. Please solve this and give me the value of the sum to infinity.
1.
Negative 1 over 3.
Negative 1 over 3.
Why are we getting such a different answers? 1 plus 1 upon 2 is 1.5. -0.5 divided by answer. So -1 upon 3, is
It's
that
negative
correct?
1 over.
Yeah, yeah.
-1 upon 3, right? Okay, that was the second part. Now the third part says the sum of the first 20 terms of the arithmetic progression. The sum of the first 20 terms of the arithmetic series. Now, the arithmetic series, after we have found the values of x, was the arithmetic progression was x, y, and x squared. X, y, and x squared. So the x value is -half. The y value is -1 upon 8. And x square value is going to be 1 upon 4. Guys, this is an arithmetic progression. The arithmetic progression is known for common difference. So the first term is -1 upon 2. What is the common difference? What is the common difference, guys?
Is 3 over 8.
Minus 1 upon 8 minus 1 upon 2. Is it coming out to be 1 upon 8?
3 upon, yeah.
Okay, now you have the first term and the common difference. You have been asked to find the sum of the first 20 terms. So you have to find S20. The formula for the sum Sn of a geometric of an arithmetic progression was equal to n upon 2
Sir,
plus n minus 1 times d. Yes, Hassan?
Sir Ahmed Rahman.
Yes, Abdurrahman?
Sir, could you repeat, like, what's the difference again? How did you find the difference?
So y, the value of y minus the value of x. Difference between the consecutive terms.
Okay.
So
Sir, can I just take 1 over 4 minus 1 over 8?
yeah, that's also fine. 1 upon 4 minus 1 upon 8. That's also going to be 1 upon 8.
Okay.
Now, Sn is n upon 2 times 2a plus n minus 1d. N value is 20. 2a, a value is half minus half. 20 minus 1 is 19. Difference is 1 upon 8. You can evaluate this result.
But I'm getting 3 over 8. I don't know why. The difference.
1 upon 4 minus 1 upon 8 is, oh, okay. I think I have done an error. Guys, just check your working again. 1 upon 4 minus 1 upon 8. Yes, Abdurrahman, you are correct. It's 3 upon 8. Guys, please make a correction over here. The difference is 3 upon 8. Okay, now calculate the result, please.
Sir, 61.25.
61.25. That's correct. Is everyone getting the same result?
Yes.
Okay, great. All right, now we are going to be looking at some interesting questions. These are the applications of APGP, arithmetic progression, geometric progression. So these are mostly going to be word problems now. So I want you to read this question, and then we can discuss it. A ball is thrown vertically upwards from the ground. The ball rises to a height of 8 meters and then falls and bounces. After each bounce, it rises to 3/4 of the height of the previous bounce. Write down an expression for the height that the ball rises after the nth impact with the ground. So let's try to understand this question. This is your ground. And a ball is thrown vertically upwards from the ground. So let's say this is the starting point. The ball is thrown vertically upward from the ground. Okay, it reaches a height of 8 meters. And then it falls. Will the ball rise to the same height back, or will it be rising to a height less than the previous height?
Less than the previous height.
Obviously less than the previous height, because it is going to, if you're a physics student, you must understand that it's going to have an impact. While contacting, it's going to dissipate energy, right? So it's not going to go back to the same height level. It's going to go to a height smaller than the previous height. And it is going to keep on bouncing, and every time the height reached is going to be less than the previous height. Okay, now after each bounce, it rises to 3/4 of the height of the previous bounce. So they have given us that it rises to 3/4 of the previous height. So what is 3/4 of 8?
6.
6. So this height is 6 meter. What is 3/4 of 6 now?
4.5.
4.5. Okay, and so on. Are you clear with the? Do you now understand the question?
Yes, sir.
Now we need to write down an expression for the height that the ball is going to rise after the nth impact to the ground. So let's say after several bounces, it's going to have an impact and then it is going to rise again. So this is my first impact. This is my second impact with the ground. This is my third impact with the ground. This is my fourth impact. And let's say this is my nth impact. Okay. So what is the height of the ball after the first impact?
6 meters.
What is the height of the ball after the first impact? After the first impact. Come on, guys.
0.
What is the height of the ball after the first impact with the ground? Here it is the first impact of the ground. What is the height reached by the ball after the first impact?
6 meters.
6 meter. What is the height of the second impact? 4.5.
4.5.
Okay. Similarly, you have to find the height after the nth impact. So we need to find the height after the nth impact. So we need to come up with the expression. Okay. We need to come up with the expression. Now, by looking at the numbers or by reading the question, what idea does the question gives to you? Is it going to be an arithmetic progression or a geometric progression? Is the height that the ball rises after every impact, does the number tells you that it's going to be a geometric progression or the arithmetic progression?
Arithmetic.
What makes you say that it's arithmetic?
Because it's decreasing after every time it passes, decreasing.
So geometric, because the common difference is not the same. There's a common ratio.
Yes, it is geometric progression because every time the next height is 3/4 of the previous height. Okay, so if I am going to find the ratio between the heights, what is 6 upon 8? It's 3 upon 4. What is 4.5 upon 6? It is 3 upon 4. So it's a geometric progression. Okay, please understand this. It is the common ratio. It is a geometric progression, and hence the common ratio is 3/4. And what is the first height reached after the first impact?
8, 8,
It is
6, 6.
after the first impact. Okay. Now, in a geometric progression, how do you come up with the nth term expression? What is Tn equals to?
A divided by 1 minus
8
r.
times r to the power of n minus 1. Okay. The expression for the nth term, not the sum, the nth term. You need to write down the expression for the height. The first height is 6. Okay. After the first impact, the second height is 4.5 and so on. You need to come up with the nth expression that after the nth impact. So it's a geometric progression. The first term is 6. The common ratio is 3/4 n minus 1. Okay. Now, if you can simplify this further, what would you get? You need. Okay. So, well, you can leave your answer right over here as well. Okay. That's the nth term expression. Is the first part clear?
Yes, sir.
Anyone who's not clear with the first part, Zores, Manun?
So won't
No,
it
sir.
be 8 as the first?
So the question has said, write down the expression for the height of the ball rises after the nth impact with the ground. So the first impact to the ground was out over here. After the first impact, the height reaches 6 meters.
Oh,
After the second impact, the height reaches 4.5. Okay, so that's why the
Yes.
first value is going to be 6.
got it, yeah.
Okay. Now, the second part says find the total distance that the ball travels from the first throw to the fifth impact to the ground. From the first throw, so after the first throw is this value till the fifth throw. Okay. After the first throw, it says throw, not the impact. My bad. It says the throw. So the first throw is over here. What is the total distance covered in the first throw? Can you guys tell me what is the total distance traveled by the ball in the first throw?
8.
No, it's going to be 16 because the ball is going to go up 8 meters and it's going to go down by 8 meters. Okay. So the total distance covered is, you need to come up with total distance. So I'm going to make a series for the total distance. The first total distance, okay, after the first throw is 16 meters. Do you guys understand why 16 is the first value? What is
Yeah.
going to be the
8
next
meter
value?
upwards, 8 meter downwards.
Yeah. What is going to be the next value?
12.
12,
12. Then
9.
9 and so on. So the progression that now I have is the progression for the total distance. Okay. Would you agree that this is also geometric progression?
Yeah.
Okay. Now you need to find the total distance, meaning how would you find the total distance? Would you be finding
sum
the
of 5.
sum? Yes, you are going to be finding the sum S5. S5 means the sum till the first 5 terms, which means that the sum of S5 would represent the total distance traveled by the ball from the first throw till the fifth. Okay. Fifth impact with the ground. So first throw, second throw, third throw, fourth throw, and fifth throw, and the fifth impact. So this is the total distance that you need to find. So the formula for finding the sum in a geometric progression was a times 1 minus r to the power of n. Okay. Sn was equal to a times 1 minus r to the power of n over 1 minus r. The first term is 16. The common ratio is, what is going to be the common ratio, guys? It's going to be the same, 3 upon 4 to the power of 5 divided by 1 minus r. Please solve this and give me the value of S5.
But I'm confused, like when do I know how to use Sn is equal to A1 minus Rn?
That is the term. If you want to find any specific term, you are going to use this formula. If you want to find the sum, you are going to use this formula. Over here in the second part, it is asking for the total distance traveled. Total distance would mean this distance plus this distance plus this distance plus this and plus this. Okay, so you need to add these terms, add these values. So you need to find the sum of the first 5 terms of this progression. That's why you are going to use the Sn formula, the sum formula.
So 48.
Do the maths. What's the answer?
48.8.
48.8 meter. Make sense?
By the way, sir, wouldn't it be possible, since it's only 5 throws, you could do 16 plus 12 plus 9, and then the next 2 throws as
Yeah,
well?
you are absolutely correct over here that because this is a simple question, you can just add that up. You can find the total distance over here and just add them up. You're still going to get 48.8. Okay. But what if the question would have said, find the sum of the first 11 throws? Then it would have been a tedious working to calculate all the 11 terms and then add them up. So the formula, the idea about using the formula is to avoid that tedious calculation. And the chapter expects you to know and use the sum formula. Okay,
Okay, sir.
are we clear till here?
Yeah.
Yes, sir.
Okay. The third and the fourth term of a geometric progression are 1/3 and 2/9 respectively. Find the sum to infinity of the progression. This is a past paper question. The third term of a geometric progression is 1/3 and the fourth term is 2/9. To find the sum to infinity, you need the first term and the common ratio. How can you get the first term and the common ratio?
So we can say 2/9 minus 1/3.
No, it's a geometric progression.
So you divide 2/9 by 1/3.
Yes, the common
Yeah.
ratio is going to be T4/T3, that is 2/9 divided by 1/3, which comes out to be
2/3.
2/3. Now, the third term was equals to 1/3. We know that the third term is equals to AR square, right? And the R value is 2/3. So you can do the math and give me the value of A.
3/4.
A/4, yeah.
Sorry, what's the value of A?
0.75. 3/4.
0.75 or 3/4, right? So A value is 3/4. R value is R value was 2/3. Please solve
Okay.
this and give me the value for sum to infinity.
Nine over 4.
9/4.
9/4. Okay. 9/4. Right. Now, part B, guys. A circle is divided into 5 sectors in such a way that the angles of the sector are in arithmetic progression. Given that the angle of the largest sector is 4 times the angle of the smallest sector, find the angle of the largest sector. So a circle is being divided into sectors, into 5 sectors, such that the angle of the sectors are in the arithmetic progression. So what is, if I say that the first angle of the first sector is A, what is the angle of the next sector going to be if it was arithmetic progression? A plus
A plus 1. A plus B.
A plus 1D. Then the next sector A plus 2D. Then A plus 3D. Then A plus 4D. Would you agree with this? This is for the
Yes.
first sector, second, third, fourth, and fifth. Right? There are 5 sectors. By the way, if you add all the angles in a sector, if you add all these angles
Total
of a
area of the
sector, what would this be equal to?
360.
360. So that's your first equation. A plus D plus A plus 2D plus A plus 3D plus A plus 4D is equals to 360. Okay. So 1, 2, 3, 4, 5. 5A plus 10D is equals to 360. Right? That is your first equation. Now come up with the second equation. The question further says, given that the angle of the largest sector is 4 times the angle of the smallest sector, the angle of the largest sector, which is A plus 4D, right, is 4 times the angle of the smallest sector. So would you agree that the second equation is going to be A plus 4D is going to be equal to 4 times A? The angle of the largest sector is equal to 4 times the angle of the smallest sector. So if you solve this, you are going to get 3A equals to 4D. That's your second equation. Solve the two equations simultaneously, you are going to get the values of A and D. So A comes out to be 4D upon 3. Okay, just solve this. What's the value of D?
21.6.
21.6.
21.6. Okay. Now, what's going to be the value of A? I'm getting 28.8. Okay. Are we clear till here? That was the working for the second part.
140.
Is everyone getting 28.8?
Sir, how did you get value of A? Okay, understood.
Just plug in D over
Yes,
here.
sir. Got the answer.
Okay, so this brings us to the end of this chapter.